We have spent decades treating software development like a commercial construction project. We draft blueprints, lay foundations, and pour concrete, acting as if every variable can be anticipated before the ground is even broken. This process relies on a linear sequence, months spent gathering requirements, charting rigid roadmaps, and committing to a master plan that locks the project into a fixed trajectory for years. This method assumes developers can accurately predict the future. It prioritizes building a machine that is optimized for a reality the creators believe will exist on launch day. That industrial mindset works in a stable world, where business structures and user behaviors rarely shift. But that version of the world ended over a decade ago. On this timeline, the straight line represents a 3-year development cycle. The chaotic lines are actual user behavior. Habits mutate at a pace that spikes beyond traditional development. The finished application arrives perfectly polished for a reality users have already abandoned. Software fails when it treats chaotic human interaction like a predictable mechanical process. This is the core of biological complexity. The behavior of the user is more fluid than the rigidity of the code allows for. To survive this volatility, software must stop functioning as a static object. It needs to be cultivated as an adaptable system that can respond to the world in real time. Rigid master plans used to be a financial necessity. Testing a single new idea required an enormous amount of time and specialized human coordination. Building even one working prototype carried a massive financial risk. AI has collapsed those costs. It functions as an economic catalyst that brings the price of digital experimentation down to nearly zero. The math of development has changed. A prototype that used to consume 3 months and an entire department can now be generated and tested in 3 days, allowing teams to field dozens of concepts simultaneously. This shift removes the need to place a massive, risky bet on finding one correct answer before the first line of code is written. The goal has moved away from building a single product in a vacuum. The focus is now on exploring the widest possible range of solutions at hyperspeed. This leads to a process called AI straining. Instead of a single monolithic app, developers release multiple, distinct variations of a product into the market at once. These strains test different core philosophies. One variation might prioritize a hyper-efficient interface, while another tests an expressive, human tone, revealing which emotional rules actually resonate with the crowd. In this branching tree, the market is the selector. User friction determines which pathways are in adoption and which grow cold. Abandoned strains provide genetic data for the next mutation. Their patterns feed directly into the survivors, thickening the glowing pathways. Human unpredictability, not the original roadmap, ultimately decides which software version is fit enough to survive. The most dominant tech products in the world rarely look like the plans their founders started with. They possess an emergent identity. A product discovers its actual purpose through interaction with the market. A tool designed for productivity can organically transform into a social space because that is how the community chose to inhabit it. Users rarely follow the intended manual. When people hack tools and create their own workflows, they assemble complex ecosystems that the original architects never envisioned. Because of this constant feedback, a digital product is never truly finished. It remains in a state of perpetual self-discovery. This reality redefines what it means to be a software company. The role of the top-down architect is being replaced. Developers are becoming digital biologists or ecosystem curators. In this new role, the team provides the environment and the initial variations, allowing the system to iterate based on the data it collects from the users. They set the parameters for a system that can effectively shape itself. Competitive advantage now belongs to the organizations that can generate and test mutations the fastest. Planning for the long term is less valuable than reacting to the present. When the code is built to react to its environment in real time, it stops being a static tool. It becomes a responsive network that learns from every interaction, and our job is to provide the space